Hello, New York University. I'm Mingyuan Chen. I'm applying to a math in finance program. I'd like to briefly introduce myself. I'm a mathematics student in College, London. Currently, my curriculum covers measuring integration, function analysis, probability theory. I think I have a solid understanding of analysis to learn advanced math topics like stochastic calculus. I'm also learning option pricing to learn the derivative pricing and hedging strategy in the quantitative finance. I think the program challenging me the most is my international research opportunity program at Vancouver. I was nominated by Imperial College London to work with one applied mathematician at the University of British Columbia. Our research topic was causal inference. It was a new research started since 21st century led by mathematicians like Jonas Peter and Berhard Shakov. People started to pay attention on causality studies because people realized that correlation sometimes failed to build status model that has a higher predictive power, and there will be overfitting problem. So causality study has a huge application in that. And people try to distinguish cause from effect using given the observational data. In the multivariable case, I will use a cyclic graph model and also Markov equivalent class to infer the causal structure. In the bivariate case, sometimes the researcher focused on developing a diffusive noise model and using HSIC algorithm to determine the independence relation between the predicted residue and the cause variable that we assumed. I think the topic I spent time investigating on is to use different generalized entropy function like differential channel entropy and the Bright score to determine the causal direction between two variables. I found my project challenging. First, there are a few papers on the entropy function, and it's an entirely new area that people has really spent time investigating on that. So it was also challenging was because that sometimes before I want to code my algorithm, I want to fully understand the theory analyze algorithm. For example, learning HIC-IC algorithm, I want to learn the reproducing kernel Hilbert space. I didn't learn LP space and the Hilbert space, the material in function analysis before because function analysis was provided in the third year curriculum at the Imperial College London. So I spent time reading the previous year's notes on function analysis and measure integration and also general topology to catch up with this knowledge. I also actively seek help from the Institute of Applied Math at University of British Columbia. They have lots of applied professors specializing in convex optimization and also statistical inference. I actively seek help from one of the CS PhD, which answer a lot of questions on the papers related to convolutional neural network. So all of my independent study built a solid foundation for me to encode my algorithm and understand these algorithms that people implemented before to make a comparison between my entropy method and the HIC algorithm. I found that the result inferred by the different general entropy function were consistent with the HIC algorithm, and it has one more advantage is that the method can be used to quantify the causal impact by each variable, and it can apply to the high dimensional data. So it implies it has a huge application in financial data because later I read on a paper explaining the relationship between financial data and the causal inference. I learned that it can shed light on stock market performance. We can use causality study to learn the causal structure among different asset performance and the political factor, market sentiment, and also U.S. foreign exchange rate. It all can influence the stock market. We know the advanced math in the derivative can hardly explain the regression model in modeling the stock. And I think that understanding causality beyond the causation can reduce the overfitting problem in machine learning and better extract the information from the high dimensional financial data. I believe that studying at NYU will let me know more about the computational method on the high dimensional data, and I think I can be successful in the area of investment strategy on the equity market. Thank you very much. See you. I really wish to join NYU society. Bye bye.